Hello everyone, I am Ayush Singh. Today I will be sharing my work on Paisabazzar project. So the outline of our project is problem statement, data exploration, cleaning and memory optimization, visualizations, data set preparation, model training and testing, model explainability, insights to Paisabazzar team or solution to our business objective, and the future work. So Paisabazzar is a financial service company that assists customers in finding and applying various banking and credit products. An integral part of this their service is accessing the credit worthiness of individuals, which is crucial for both loan approval and risk management. The credit score of a person is a significant metric used by financial institutions to determine the likelihood that an individual will be able to repay their loans or credit balances. Accurate classification of credit score can help Paisabazzar enhance their credit assessment processes, reduce the risk of loan defaults, and offer personalized financial advice to the customers. In this context, analyzing and classifying credit score based on the customer data can improve decision-making process and contribute to the better financial product recommendation. This case study aims to develop a model that predicts credit score of individuals based on the various features such as income, credit card uses, and payment behavior. And the final objective we have here is developing of a model that can predict credit score. So simply we have to predict the credit score. And why credit score is important? Because it will help us to know that whether the individual will be able to repay their loans or credit balances. And accurate classification of the credit score can help Paisabazzar team to enhance their credit assessment process, reduce the risk of loan defaulters, and offering personalized financial advice to their customers. Okay, so let's now move to data exploration, cleaning, and memory optimization. We have simply imported pandas and numpy. So now we are looking at our original data set. We have 28 columns and 1 lakh rows. We have ID. This is unique for the entire rows. We have customer ID. For a single person, single customer, we have 8 rows, and same we can find for these 8 rows. We have the same customer ID. It is unique to particular customer. We have age, we have SSN, occupation, annual income and monthly enhanced salary, number of bank account. There are some more columns here. Credit mix, outstanding debt, credit utilization ratio, credit history age, payment of minimum amount, total EMI per month, amount invested monthly, payment behavior, monthly balance, and finally we have a credit score. So basically we have 3 labels: good, poor, and standard. So overall we have 1 lakh rows, but we have 8 rows for each customer. So if we divide by 8, we'll get around 12,500 rows, unique rows, 12,500 rows for each customers. Now let's quickly look for dev.info. So basically it helps us to gain understanding about the columns, number of non-nulls, like, and their data type. And the total memory uses we can see is around 21 MBs, and we have 7 objects. N64 is 3 columns, and 464 is 18. Okay, so if you want to check it again, like we have already df of memory uses dot sum, the same we can see 22 MBs. Okay, this is also same 21.4 MBs. But basically this method does not give us the clear memory uses of the object or string type we have stored. So basically if you want to know more accurate uses of object data type, we should use this type is equal to true. So the actual memory uses, it comes around 69 MBs. So we have around 69 MBs of memory uses. So we will try to optimize this and also look for data exploration, and we'll move according to this data types. First we will explore int, then float, then we will go towards object data type. So we have 3 columns for int data type: ID, customer ID, and month. If you look over month, we want to know the value counts. So we can see that for we have 8 months, 1 2 3 4 7 8, and each values we have 12,500 unique users. If you want to see the number of uniques for each data type, sorry, each int columns, so we have 1 lakh unique values for id. For customer id, we have 12,500 unique customers on our dataset and 8 months. Since id is unique for all the rows, we can simply drop this. And I also wanted to show that we have 12,500 customers, and 8 for they have dataset for each month equal to total rows, that is 1 lakh. And also the number of months we have simply basically is 1 2 3 4 5 6 7 8. So we don't need int 64 to store it, we can simply store it into int 8. So we can save some memory here. And we can also see that the customer id, also check the range of customer id. I have used describe, so the max value of customer id is around 51k. So we should also try to see that if we can find in 32 or 16 to handle this range. Okay, so if we look for np.info and np.int16, so basically the range for int16, the range in 16 can basically hold or store, it goes up to 33k. So we can't store customer id here because it varies up to 51k. But if you look to in 32, okay, it's a huge number, we can definitely store here. And we also want to check like it's 64. So if you see that in 64 has a very huge variation, and we simply don't need like that much extra space, so we should definitely like to reduce space. Okay, and why I'm trying to reduce the space, because the pandas is basically in place memory operation. So basically it uses ram each time we do perform our calculations, so it is always better to reduce the space. So here we are converting data type, the month to int 8, customer ID to int 32, and we are dropping the column ID. We're also checking the memory users and the total. So initially we had around 69 MBs, close to 69 MBs, and now we have moved to 67 MBs. Okay, around 2 MB drop. Let's now move to float. We have a lot of columns in floats. Okay, if we simply look for info of especially float data type, so here we can see, and I try to check like the range for like unique values for age. So it varies from, the max was okay 38, we had 41, we had 45, 46. Okay, so basically we don't need like in float 64, only in 8 to suffice. And why int? Because we, if you check the values, they are not decimals, they're simply numbers, like whole numbers, all natural numbers we can say. So we don't need point 0, we simply can store as 38, 28, 31, and our work will be fine, like our system will work very fine. So then simply I moved converted the age to int 8. After that I simply went to convert all the remaining columns, like when I use the dot describe here, all the remaining columns, the data type. And what the method I use, I simply look the max values, like here I wanted to check like, and I tried to find which like float 16 8 would be better to store it. And there is no float 8, basically float start from 16 and 32, but we had int 8. Okay, so see, we didn't start from float 8, we simply started the range from float 16. So here the max value it can store is around 65k. This is 10k into 6.5, around 65k. So we should also got an sorry float 32. So this is its variation. So we can simply look on the range of each of the columns, and I simply then converted it to like the data type which is required to store all the possible range, all the possible variation which can exist in that column. So let me just show it a particular one. Oh, here we say annual income. It is around 1,80,000. So if you look 1,80,000, so basically we can't use float 16. We have to must go for float 32. So if you look for annual income we have float 32. Also SSN is float 32. If you look for SSN, it's a very huge number, up to 0 power 8, 10 power 8. So variation 32 is up to 38, so you can simply store it. If we look at the rest of the values, it's maximum values are all less than 65k, 25, 29, 17, less than 65k. So we can simply use float 16 to store all this. And after doing this, like I got total memory users around 56 MBs, so basically a reduction of 15 MBs. Then I move to object. So in simple term, what I'm doing is I'm just trying to find the optimal uh, data type which I can use to store that kind of that information. I did the same for object. So basically, okay, first I drop the name because name is obviously not important in our prediction. So after that, I went to find that value count of type of loan. So basically, we have a huge number of uh, unique values in the type of loan. So I decided to drop it, and I also wasn't sure how to proceed with this. But definitely, yeah, if we have someone guide us, so let's say a domain expert in this, we can try some do some feature engineering if this columns is really very important. Basically, I simply dropped it here. After that, I basically converted all the remaining columns like occupation to category, trademarks to category, all the objects to categories. So these are occupation, type of loan, trademarks. These are all objects. I simply moved them to category. One point to note is I'm not changing the text to numbers. I'm simply converting the object to categories. I will. So how did I store? If I will check. Okay, so basically this is my function tail here. What I have done. This is called concept of chaining. So after that, I created a function develop process data. I just simply use this, and then I simply loaded the original data set. I called the preprocessed data function. I checked the memory users. So basically, I forgot a point. Basically, after converting this object to category, I simply moved from 69 MBs to 5 MBs, so around 7.2% of original memory users. And this seems not very useful for like our use case because it's simply working on a 1 lakh data set. But in future, if you're working on millions or billions of rows, obviously, if you're working on companies, and so this will be a very important point to ponder or work on. So this is our df after pre-processing. So when you can see there is no text. I haven't converted the text to any other encoding methods like text to numbers, or but I simply converted the object to categories. And you can see earlier age was float. I simply converted into int. After that, I can check therefore info. So I can see that I have converted all the data types. After that, I will save it to from Parquet file, because if I will save to CSV, then all the transformation I have done in data type, it will be lost. So basically, if I will save to CSV, then it will again go to object 464, object 464, and here will go to N64 and 64. So all the data types transformation I have done, it will be lost. So that's why I'm going to Parquet. So develop Parquet. I have saved it to in a Parquet file. So this is the file. If I try to load it, I won't be able to read it because it's stored the data in a kind of binary format. CSV is easy to read, but we can't do so in Parquet format. Okay, later on I can move to visualization. Basically, I divided into two sections: categorical features and numerical features. If you look to categorical, we have first credit score, our labels. So we have a lot of values for standard, and then poor, then good. And also standard was a bit like intermediate between good and poor, so it was a bit expected to me like this might be possible. But here we have good, the count of good is less than count of poor. So this part was very interesting. And occupation, if you want to see the number of counts, it is almost the same. So we might also try dropping this column. I haven't done this in this project, but yeah, definitely we can try this. And this was a bit unexpected to me because I didn't expect that all the occupations will have like similar counts. Maybe the dataset was constructed in that way. And also, this is more interesting. Why this might be the fault of data collection, but if we look at this part, we will see that the amount of good, poor, and standard is almost very close, like for all the occupations. If you see that, like there's obviously some pattern of variation, but there's not some huge variations. So this part was really very like, I didn't expect this part. We can also visualize as a count plot. So basically this was a his plot, but it's always better to visualize as a count plot, is easier to see. Then we have credit mix. So I did the same for all the features. First I did the like univariate analysis, then I did it like a bivariate with comparison with credit score, our label. The problem I faced was that problem we were provided in that the columns were not clearly defined. So I was feeling the lack of any like domain experts or maybe the one who has collected data set to explain me all these concepts, like what how things are influencing. So now we can move to manual features. We have monthly balance. I did a box plot for that, and I did it versus monthly balance. And if you try to look at this, the median of the monthly balance of the our customers, the poor is the lowest, then is standard, and then is highest for the good. And this is like expected for us. Like, and also if it's try to look the interquartile range, this part, like this is highest, like for the good part, for the good credit score. And then we have age. This is also an interesting like plot. We can see that we can, if you want to classify this chart or plot into, let's say, a numerical or categorical feature, we can see that like here we can see almost a kind of block. Let's we do it like a one, and we can do these as zero. So we can express our entire, we can say, age column maybe as two three categorical feature or two. But I haven't tried this, I'm just thinking out, maybe I can do so, we can do so in future. And this is credit score and y as age, and also remove the outliers here, so flag is equal to false. And we can also see the similar kind of trend for the poor, the credit score, the age is lower, and for the standard age is more, and for the good age is higher. So we can see like there must be some kind of relation with age, like maybe with when people grow, they have more experience, they become more aware that how should be using their credit score, or how should be like handling their money. From there we have SSN. This also, there was not much of variation. Then we move to annual income and monthly enhanced salary. So they have basically a similar plot, but this was a bit skewed. This is right skewed. I moved to the box plot. There were some features like number of bank accounts, number of credit cards, number of loans, number of delayed payments, and number of credit inquiries. I simply did univariate analysis for them. Then we have features like outstanding debt, credit utilization ratio, and credit stage. They're also similar. We can simply like use like some kind of category encoding. It's like A, B, C, D. We can try this. This is also similar. A, B, and C. So with this is total MI per month and amount invested monthly. Now let's move to dataset preparation. So we're using standard scale and ordinal encoder, and we're also using column transformer to like keep them together. So we have already loaded our like clean dataset, the Parquet file, and we are defined our label, and we will be dropping credit score, okay, to define XY. Now if you see our labels are basically in form of good, standard, and poor, but we need to convert into a form of numbers, so I use the mapping for that. So then I like separated the numerical and categorical features. I defined ordinal encoder for categorical, and standard scaling for numerical features. And I kept under preprocessor. If you want, just try to look at what it is. So it's a quite nice visualization. We can see this is the name of the ordinal encoder and all the columns we have. Same goes for standard scale or the numerical columns we have under X num features. So I used the split of 20% for text and kept I certify is equal to y to ensure that the ratio of the labels classes would be same in the train and the split. And then I applied the fit transform for the train, and the text we only use transform because we don't want to have the data leakage or learn from testing data. Then we move to model training. I use four models: logistic regression, random forest, XGB classifier, and cat boost. And for metrics I use accuracy score, balanced accuracy score, and classification report. First, the logistic regression. The solver I kept was LBFGBS and max iteration was 2000. Okay, for reproducibility I kept random set 42, and I use class weight balanced because if you see the labels we are not have quite like equal number of counts, so I kept balance here, and I kept verbose 2 for like these this kind of results. So the score I got was around 65%, and if you look for balance accuracy it is 63.7, and the F1 score for each level 0 1 2 was to 65%, 67, 62. And then I went for random forest. Okay, so here also kept class with balanced, random state for reversibility, and above estimators as 100. But this is basically a default value, but we can change also this. So this was our best performing model. The accuracy value got 83.5%, and the balance accuracy was 82.48%. Sorry, accuracy was 83.5%, and balance accuracy was 82.8%. And the F1 score we got was also better, like close to 84%, 85%, 81%, like 80 plus percent for all the labels. I'm also trying to understand like the feature importance from the random forest model. So this was basically the plot: the credit history age and the number of delayed payments, the month, total by month, and the number of credit inquiries. Like these were few of the major contributors in getting our predictions. Then we have our XG boost. So here the accuracy will got for 79.4%, and the F1 score for for the labels 78%, 81%, and 76%. And we have our cat boost model. Cat boost model had accuracy of 78.8%, and this is all F1 scores. I also try to see the feature importance from cat boost. So it also the credit history is the month and about daily payments. These three work similar in both random forest and cat boost. So far random forest are outperform other models with 18.59 accuracy. But the problem here is model explainability is we can't look for like any particular row, or it's basically an importance of features for an overall prediction, like overall we can say. But if you want to go more depth, we have to use SAP. So basically it is used as a model explainability tool, we can say. So I use SAP to explain the RF and the SAP values. I only loaded first 100 rows. I was trying to get a plot. So basically we try to see, I have kept row index 1 and class label is equal to 0. Class label is 0 for poor, basically poor credit score. So these were the feature importance we have for each of the columns. So this is basically our plot. It is same for good credit score. So this expectancy FX, expected FX, basically this shows kind of mean score. On the top of that, all the impact created by each feature is divided by minus and plus. And the summary plot for like for poor label for our entire 100 rows is this. You can see we have got good impact of credit history age and about delayed payments in the positive side. And if you look in the negative side, we have impact on outstanding debt here. Also number of credit cards a bit. So we can interpret in this way. So I've also written the insights. Poor credit score are influenced by low credit history age, high number of delayed payments, frequency of credit inquiries, and high outstanding debt. I also look for like the standard credit score. So this was the plot. And for the good credit score, so the high credit history age and low delay from due days and higher income and investment. So really they give us a better insights of our predictions or we can say, if you want to use these models in our business cases, we can't just simply treat it as a black box. We want to understand like why model the made its predictions. So in this case, these SAP as a tool for model explainability is very important. Insights to Paisabazzar team, but sorry, insights to Paisabazzar team. First, is customer segmentation. We can segment users by SAP-driven features like credit history, age, and about delay payments to target high-risk groups with tailored financial advice or pre-approval offers. And we can do some proactive interventions. We can use SAP values to create explainable scorecards to guide the customer toward improving their credit score, like reducing EMI load or delaying fewer payments. Transparent recommendations integrate local explanations from SAP into customer interface for transparent financial decision support. Like we can show your credit card is likely impacted by high EMI and frequent credit inquiries. So like the customer can improve their credit score and they can get loans easily, and also it will be helpful for our Paisabazzar team for the future work. Like I really felt the need of an domain expert or the person who has collected data set, because for doing data analysis I felt like I was not able to completely understand the columns. And also I should do more experimentation of with feature selection in future. Okay, thank you.